Okay, we've been talking about positional numbering systems, and today we're going to look at how to decode binary numbers. So the first thing we should do is review binary. Binary is a base 2 numbering system. This means two things. First, there are two symbols that we use, the 1 and the 0. And second, the columns are powers of 2. So we have our 1s, our 2s, our 4s, our 8s, our 16s, our 32s, and so on. And you'll notice that each column is 2 times the previous column. 1 times 2 is 2, times 2 is 4, times 2 is 8, and so on. By convention, we arrange these columns so that the 1 is our rightmost column, and subsequent columns ascend to the left. And this is consistent with how we represent numbers in decimal. So let's go ahead and decode this binary number, 100110. So the first thing we should do is place these digits under their binary columns. So this 0 is in the 1s column, and this 1 is in the 2s column. And then we have a 1 in the 4s, and a 0 in the 8s, and a 0 in the 16s, and a 1 in the 32s column. And you'll note that we always either have a 1 or a 0 in each column. We can't have 2 1s, for instance, because then we would have 1 2. And we can't have 2 2s, for instance, because then we would have 1 4. And once we have these numbers in their columns, we note which column values have a 1 in them. And so we see that there's a 32, there are no 16s, no 8s, but there is a 4, there is a 2, and there are no 1s. And because each column either has 1 of that value or none of that value, binary is much simpler to decode than decimal, because we just have to add the column values for the binary numbers that have a 1. So a 32 and a 4 and a 2. And those add up to 38. So this binary number, 100110, is equivalent to the decimal number 38.